All right, so for this lesson, we're going to be talking about synthetic division. For the last lesson, we just got done with long division. Long division actually will work with any set of polynomials that you are dividing. However, synthetic division does not. So synthetic division students find to be easier, but it doesn't work with every single type of polynomial division. So when does synthetic work? So synthetic is going to work when the divisor, so when I'm looking at my divisor here, my divisor is x minus 4 when my divisor is a linear binomial. Okay, so when I say a linear binomial, that means it has to be in that form x plus or minus a number. So that is only time that it's going to work is when I have x plus or minus a number. And I think most time they will actually call it k. So I'm going to erase that right quick, just so that I'm using the same value. So they're going to call that k. So keep that in mind. If it's not in that format, then you need to use long division. All right, so how do we deal with synthetic? So the steps are over here, 1 through 6. So in order to set up the synthetic division, the first thing you're going to do is you're going to figure out what are my coefficients that I'm going to be using. Well, in order to figure out the coefficients, it has to work the same way. It still has to be in descending order. I still need to make sure that I put any placeholders where there's pieces missing. And then the other thing we're going to have to do is we're going to have to determine that k value that we're going to be using. Okay, so let's go ahead and start off here. I should be able to look at my problem and I should be able to see that I'm missing the x variable piece. So we're going to need to make sure we put this. Now you don't have to rewrite it every time like I'm getting ready to do. I just want to make sure that everybody's clear of where we're at. So I have 3x squared minus 2x squared. We're missing the x, so we're going to put the placeholder plus 0x minus 150. And that's going to be divided by x minus 4. All right, so when we set this up, the first thing we're going to do is we're going to figure out what my k value is. So right here, I have x minus 4. So x minus 4 is a linear binomial. The k value is the number in which I'm trying to determine is going into each value. So I'm going to set that equal to 0, and the actual k value that I'm going to be using is positive 4. So make sure you are very clear about that. The linear binomial is not the minus 4 that we're going to use. We're going to be using the positive 4 because that 4 is the number that is going to be manipulated. So we're going to take that 4. I'm going to put it in a little box. I know that's the one I'm going to reference. And then I'm going to bring down my coefficients for each piece. So when I'm looking at my coefficients here, I have the coefficient 3, I have the coefficient -2, 0, and -150. Okay? So I'm going to basically do some multiplication and addition, and we're going to repeat the process over and over again. So the way this works is you're going to take your first coefficient and you're going to bring that coefficient down. That's going to be the leading coefficient of the new polynomial that we find after this division. So then what you're going to do is you're actually going to multiply. So what are you multiplying? So in this problem, I'm going to take the 4 and I'm going to multiply the 4 by the 3. So 4 times 3 is going to give me 12. And that's going to go underneath in the new column. And in the next part, you're actually going to add. Okay, so we're going to take -2 plus 12, and that's going to give me positive 10. Now you're going to repeat this process again with the 4. So we're going to take the 4 and we're going to multiply that by 10. So 4 times 10, that's going to give me 40. And we're going to add those values. All right, so we have 0 plus 40. That is going to give me 40. And once more. So we're going to take our 4, multiply it by 40. And that is going to give me 160. We're going to add that column. And once I add that, this last number that I get is 10. Whoops, wrong pen. That number is going to be 10. That last number is your remainder. Okay? So when I set this back up, we're going to answer it. So we started out with x cubed. So when we put these all back together, the 3 is now going to be 3x squared, because it's going to drop down 1 because we just divided it. Then it's going to be plus 10x plus 40 plus a remainder of 10 over the divisor. Now remember, the divisor was originally x minus 4. And there's my synthetic division. Okay, so let's try another example. All right, so for this particular problem, I have x squared minus 13x minus 48, and that's going to be divided by x minus 3. So again, this one is in that format, x minus k, so we can use synthetic division here. The k value that we're going to be using is -3, because if I take x plus 3 and set it equal to 0, it'll solve for -3. So we're going to do -3. And then my coefficients are 1, -13, -48. They're already in order, nothing's missing. Okay, so we always bring down our first one, and then we multiply. So -3 times, so -3 times 1, that's going to give me -3. Then we're going to add that column, so -13 and -3, that's going to give me -16. And then -3 times -16, so we're going to repeat that process again. So we're going to do 3 times -16, and that's going to give me positive 48. So -48 plus 48 is 0, so my remainder for this one is 0 this time. So we do not have a remainder. So when I write my division for this, my quotient, so when I write my quotient here, we had x squared, so when we write this is 1x, and technically 1x, we don't need that 1. So we're going to erase that from our problem. So x minus 16 with no remainder. All right. So then number 2, same thing. I have x cubed minus 8x squared minus 22x minus 15. I have x minus 5, so my k value here is going to be positive 5. Everything is in order, no placeholders needed, so my coefficients are 1, -8, -22, -15. Bring down my 1. 5 times 1 is 5. Add that column, that gives you -3. 5 times -3 is going to be -15. Add that column, so we have -37. All right, and then multiply 5 and -37. And we get -185. And then we're going to add that together, and you should get -200 is your remainder. All right, so when we put this all together, we started with x cubed, so this is going to be x squared minus 3x minus 37 minus 200 over the divisor, which is x minus 5. All right, and we actually already did number 3. I think we did number 3. Yeah, we did. We did number 3 as the example before, so number 4. All right, so when I'm looking at number 4, I have x to the 4th, then 7x squared, 15x plus 9, so we need a placeholder here. So we're missing that x cubed part, so this is going to be, so we have x to the 4th plus 0x cubed plus 7x squared plus 15x plus 9. So when we look at this, we should figure out that our k value is going to be negative 1. So negative 1, and then my coefficients are 1, 0, 7, 15, and 9. Bring down my first coefficient, which is 1, multiply. So negative 1 times 1 is going to give me negative 1. Add that column. 0 plus negative 1 is going to be negative 1. Multiply negative 1 and negative 1, which is going to give you positive 1. Add that column. It's going to give you 8. Negative 1 times 8 is going to be negative 8. So then we add that column, and that's going to give us 7. Negative 1 times 7 is going to give me negative 7, so I have a remainder of 2. So my division is going to produce a quotient. So we started with x to the 4, so we're going to drop it down to x to the third minus x squared plus 8x plus 7 plus 2 over the divisor, which is x plus 1. Okay. All right, so from here, I'm going to come back to these problems about is it a factor. I decided to split that up, but I am going to talk about what are they talking about when they say using synthetic division, and they give us some function notation. So when they give us this problem, this is basically saying that I'm plugging in x for that 2 value, which is actually talking about a 0 or an x-intercept, which synthetic division, when we get to the next part, when we talked about the remainder and the factor theorem, this will make a lot more sense. But my k value in this problem is 2 because it's not actually in the linear binomial. It's as if we've already taken it out. So it's basically me replacing this x with a k here. Okay? So your process is still the same. It's just about identifying what you're using. Okay, so I do need some placeholders. I need a placeholder for x squared, and I need a placeholder for x. And now we're going to do our synthetic. So 2, so that's going to be 1, 0, 0, negative 2. Bring down your first one. Multiply, that's going to give me 2. Add, that's going to give me 2. Multiply again, so 2 times 2 is going to be 4. Add again. 2 times 4 is going to be 8. Add again, so my remainder is 6. The last number, again, is always the remainder. So we started with x cubed, so we're going to drop it down to x squared plus 2x plus 4 plus a remainder of 6 over the divisor. Now here's the part. They didn't actually give you a divisor this time. So what is my divisor for this problem? Well, if my k value is positive 2, if I were to put the 2 back in, you're doing the opposite. So that's going to be x minus 2. Okay, so just keep that in mind. Same thing. So we have another one. So this one says let this be the 2x squared, and minus 3x minus 1 is k equals negative 3, a 0 of this function. So in order to be a 0 of the function, the remainder has to be 0. Okay, so in order to be a 0, the remainder has to be a 0. Okay, so basically they're asking you if I do this problem and I work it out and I get a remainder of 0, then k equals negative 3 would have to be a 0. So we're going to take negative 3 because they already told us what the k value is, and my coefficients are 2, negative 3, negative 27. So that's going to be 2 times negative 3, that's going to be negative 6, negative 9. So negative 3 times negative 9 is going to be positive 27. So my remainder is 0. So this is a 0 of that problem. So the answer is yes, because my remainder is 0. And if you need any extra help with this, don't forget I have office hours from 2 to 3, and I have it on Thursdays from 6 to 7.